Tēnā koutou katoa, he mihi mai oha, he mihi aroha ka koutou, nau mā hara mai ki tēnei hui ipurangi, te hui topa e pāna ki te hau o te whau. Kei te whakapuare te hui i tēnei ahiahi mo tētahi karakia. Kei noi tātou. He honore, he kororia ki tā atua, he maunga rongo ki te whenua, he whakaro paihinga tāngata katoa. Hangaia e tā atua he ngā hau, ki roto ki tēnā o mātou, whakatōngia tau wairua tapu, hei awhina, hei tohu i a mātou, hei aku hoki ki ngā taonga tiku iho, ake, amini. Ngā mihi.
Ngā mihi nui, Robin, for that beautiful karakia, and kia ora tātou. I'd like to extend a very warm welcome to you all today. It's wonderful to have you all with us. My name is Carla and I'm part of the team here at EcoMatters, and I'm really honoured to be your MC for today's webinar, Simple Steps to a Healthier Awa. I would like to take a moment to just introduce the support team. So if you could wave out so that everybody knows who you are. A big warm welcome to Anna, who is our online chat and audience support person, to Pam, who is going to be our timekeeper today and also a presenter, to Amanda, who has project managed this event, and to Kirill, who is offering tech support. Thank you very much. And with that note, I'd like to pass over to Jinny.
Thank you, Robin, and thank you, Carla. Tēnā koutou katoa, taloha ni Pacifica greetings. Ko Jinny Baker toko ingoa, ko Pākehā te iwi. I'm working as a social scientist with ESR, and I'm based in Porirua, Wellington. And next slide. So today I'm going to be introducing our team and the kaupapa of two projects that are based in the Whau, the Emerging Organic Contaminants Project, or contaminants that we're recognising to be of emerging concern, and the aim to Aotearoa impacts and mitigation of microplastics projects. And I'd just really like to begin by thanking our key partners, Te Kawerau, Maki, Robin and Josie, and Carla, and the huge team at EcoMatters for the very warm welcome and the space to connect today. I'd like to acknowledge all the people on the call today too for their focus and commitment. It is a Sunday. And it's amazing that you're here. I think it's been a really hugely disruptive year. There's been a lot going on that we haven't been able to control this year. And today we've got the opportunity to consider things that we can control and some changes that we can make in our local environments. So just a huge thanks to everybody for responding to this call to action. Next slide. I'd also like to acknowledge the work of our national partners in this space, particularly Paracore, as well as Te Ao Marama Ngai Tahu in Mirihuku Southland, which is a case study for our Emerging Contaminants project too. And the guidance from this project from our advisory groups Te Kahui Waiora in AIM 2 and the National Advisory Panel in the Emerging Contaminants Project. Thank you too to Auckland Council and agencies and other really important local initiatives such as the Whau pathways that intersect with this kaupapa too. We have a commitment to te riri responsive and highly collaborative approaches to ensure research that's useful for the community. Next slide. And grounding in a local place has been hugely important for the project methodology. We've landed on a kaupapa to support the community capacity to act to enhance the health of the whau and to support an understanding of the journey from macro to microplastics. It's really challenging to respond to things when they get to a micro stage in our catchment. So we're looking at how that litter gets into the stream in the first place as places that we can mobilise our action also. And to help communities be aware of some of the unseen dynamics and processes in the catchment area. Next slide, please. And just to touch on some of the methods that we've been using to ground the collaborative approaches, very briefly, some soft systems and qualitative approaches here. Next slide, please. And then to look more at some of the activities that we've been supporting in the project to date also. Just to mention the EcoHub Market Day, of which our on-Zoom online call today is a replacement for this being held in person. And to acknowledge also the work that has been done to date in the systems effects mapping survey and in Robin's work with the cultural, looking at the sites of cultural and historical significance there in the area too, which Robin will talk about in a little while also. And then Pam and EcoMatters have been doing a lot of work on the streamside cleanups, and we have a couple of important student projects which are nested into the streamside cleanup work. Matthew Perriman is going to be talking a little bit today on kaupapa Māori brand audit approaches that are aligned with those streamside cleanups, as well as Anastasia Zalata's research, which Kevin Simons from University of Auckland will be talking to a little bit more today too, looking at the distribution of microplastics in the catchment places. And next slide, please. And I guess just to note, these are two big projects, multidisciplinary teams looking across work with government, industry, iwi and communities, using novel methodologies, which Louis is going to talk about more soon too. But these are complex problems, they're wicked problems. They're not easy to solve or resolve. And we're looking at balancing the benefits of chemicals and plastics to society whilst also trying to mitigate and reduce their environmental impacts. And we're all very deeply embedded in these plastic economies and in using chemicals. So just our final slide today, just to introduce the team who are going to be talking more. Robin Taua-Gordon, Hamish Allen from the Auckland Council is looking at heavy metals monitoring in the area and sharing some data with you on that, as well as Kevin Simon. And then we have Grant Northcott and Olga Pantis, who are going to be talking about the microplastics research. But I will pass you on to Dr. Louis Tremblay without further ado, who's going to look at the emerging contaminants results with us. And thank you all again. Kia ora.
Kia ora tātou. Thank you very much, Jinny. And yes, so I'll talk about the two projects that Jinny has mentioned, the emerging contaminants and the microplastics. So Grant and myself are talking on behalf of a whole range of colleagues, and you will see some of their organizations here. So it is really a multi-institutional, multi-expertise project. Next slide, please, Kevin. So just to give you a quick overview of the structure. So here in the light blue, you have all the research organization and the particular expertise that they're contributing to the project. And then here in the gray, you have the two study sites. Jinny mentioned that we're also working in Southland. So the Whau is the area where we're working with tangata whenua and in partnerships with regional councils. And also, we really want to reach out to the wider community. And this is why this exercise or this activities is part of. And then Jinny has mentioned the National Advisory Panel. because I think we don't want to work in isolation. We want to make sure that our work remains focused on issues of impact, of importance. So you have members from regional councils and various government agencies that are working in that space. And then overarching all this, we've developed a national strategy to manage emerging contaminants in New Zealand. And I will talk about it because this is what gives us the wider vision of what we're trying to achieve. Next slide, please, Kevin. So we're talking about chemicals and plastics. I just wanted to make sure the connection between plastics and chemicals. We often think of plastic as being those very inert material, but they're not. Every plastic contains a range of chemicals, and those chemicals are added to the plastic to give it particular characteristics that are required. So here you have all those different functions that plastics are bringing. And the first one is plasticizers. And then we're all familiar with BPA or bisphenol A, which is, a very biologically active or toxic chemical. And then as you can see here in this column, you have the percentage of those particular chemicals in the plastic. So for plasticizers, it can be up to 70% can be contained in the plastic itself. The issue here is that they are not chemically bound, so they can leach out from the plastic as the plastic ages, from that macro to micro process. And then they can cause affects or impacts the organisms that are exposed to them. So a big component of our research is to look at what are the impacts of those chemicals on our biota. Next slide, please, Kevin. So I just wanted to emphasize the size of the challenge that we're facing here. It was mentioned a few years ago that the sheer number of chemicals that are being introduced on the market or are on the market really outpaces our ability to assess their risk. So we have to be very strategic on the way that we're targeting those chemicals that are posing the highest risk. And this has also been recently highlighted by a report from the Parliamentary Commissioner for the Environment that's with a focus on how can we better regulate chemicals and monitor them once they're entering the environment. Just to give you a bit of an idea, here in Australia and New Zealand, there's only about 200 of over 10,000 of chemicals that are routinely monitored, and it's not everywhere because you can see that it's quite impossible to monitor them all. And I just wanted to add a few photos here and the link between community and where those chemicals are coming from. Every time we jump in our car or flush something down the sink or use chemicals around the house, so we are contributing to the problem. Next slide, please, Kevin. So one of the areas that we're looking at is the role that contaminants can play in developing antimicrobial resistance. Again, there was a report that was recently released by Juliette Gerard from the Prime Minister's Science Advisor that AMR is a major problem that we're facing as a society. You can imagine if you go to the hospital and you have an infection, and then we no longer have chemicals or medications that can fight this disease. So again, there's a lot of linkage between antibiotics and the development of AMR, but we wanted to investigate what were the wider range of emerging contaminants and how they could promote AMR. What are the mechanisms behind? Because overall is that what the overuse of antibiotics selects for those microbes that are resistant, and then those can then reproduce more, and then this antibiotics becomes obsolete basically. So colleagues at Massey and ESR are leading this objective. Next slide, please, Kevin. So Jinny mentioned that chemicals or contaminants is a wicked problem. And I just wanted to point out a few things. That the reason it's a wicked problem is because chemicals have enabled many improvements to society. If you think about the use of pesticides in increasing food production, storage, also all the drugs that have been used to keep ourselves healthy. So this is always the balance between how can we better use the benefit of chemicals without having the adverse impacts. And that really is that balance that we want to reach. And then more and more there's a push for a do no harm philosophy. So using chemicals that are more sustainable and then don't cause any adverse impacts once they are released into the environment. And then again, here a few photos to just provide some sources of where those chemicals come from. I mean, here these are the sorts of chemicals that are in every household. If you think about detergents, cleaning products, personal care products. So if you have a look at the back of those bottles and look at the list of ingredients, and then you see a lot of those, we end up measuring them in the environment. So again, we know the sources. So how we manage the products and chemicals that we use every day can have a big impact. And I'm just having another photo of a dog here. There's close to 1 million dogs in New Zealand as we speak. And then they all have a major impact, and then including those little do bags. So we've taken away the plastic bags from grocery stores, but then we're producing 1 or 2 of those dog. So it's just pointing it as an example of how we can reduce our footprint at the source. Next slide, please. And finally, from my side of things, I wanted to just give a quick overview of the national strategy on EOCs here in New Zealand. And it was, the overall is about a sailor Leviathan while it is yet still young. I mean, from environmental scientists, we're dealing with a lot of legacy stuff. So some decisions or some chemicals that have been used in the past are still causing impact. So what we're trying to do here is, if now we can stop it, so the chemicals that we're using are not going to cause, legacy issues. So how can we be better key ourselves? And then we all need to play a role in this space. And then using the up the pipe solutions approach or framework that, what is really essential for us. So on that, I'll pass it on to my colleague, Grant.
Thank you, Louis. Oh, great, you've got it up there, Kevin. Kia ora tātou, ko Grant Northcott, aho. First, I'd just like to acknowledge the contribution of Te Kawerau and Maki to the 2 research programs, both as kaitiaki of the Te Whau Rohi, and for their continued support and contributions to the research programs. And similarly, to our thanks go to Auckland Council and our partners and colleagues there who are providing us advice and access to some of their state of the environment monitoring sites in the Whau catchment. And lastly, my co-leader of the AIM2 microplastics research program, Olga Pantos from ESR, who kindly prepared the slides of the microplastic results, and our research partners, Sion and Rotorua, who completed the analysis of microplastics. First, I'd just like to talk about a brief summary of results from the analysis of chemicals within the Te Hau catchment. And we've sampled a range of water samples through the catchment and analysed them for biological response using bioassay toxicity responses. And what we've observed is that there's a range of toxicity responses within each site and between each site. So it's quite a complicated picture. In the sediments, we also analyse sediments and have analysed them by the same range of bioassays, and they've produced the greatest number and the highest biological response. And that's compared also to our Southland study sites where we've looked in a agricultural catchment and around the urban catchment of Invercargill. So the sediments in the Te Hau catchment contain a complex mixture of different biologically active chemical residues. And what we're doing now, the next step, is we're comparing those biological responses at each sampling site together with Auckland Council, looking at what's known about the land use within the catchment and around those sample sites, both in terms of urban and industrial intensity, but also with respect to known stormwater and sewage overflow discharges, anything about historical contaminated sites and historical landfills, because there are a number in the Whau catchment. The next set of results I want to talk about is the analysis of microplastics in mangrove or in sediments at the mangrove mudflat interface. Next slide, please, Kevin. And so we sampled in 2 sample sites in the Whau, at the lower Whau, which you can see on this photo on the left, and the upper Whau. The lower Whau sampling site is at Timothy Place within the industrial zone of Avondale, and the upper site was at Queen Mary Avenue Reserve. So it's more firmly set in a urbanised suburban development area. And what we've seen is a predominance of fragments, different types of fibres, and bits of plastic film. Next slide, please, Kevin. So when we look at the large microplastic residues, and by large I mean greater than 0.3 millimetre diameter, if you look at the bars up on the top right of the picture there, you can see it's dominated by orange and blue. So that's plastic residues made up of polypropylene and made up of polyethylene. And what the predominance of polypropylene is due to it being present. It's the plastic that's used for bottle tops, on milk and drinking water bottles. It's also used in a wide range of food packaging. So the plastic pots that are used for yogurt and similar things. If we look at the smaller microplastic fraction, and that's less than 0.3 millimetre size, and we see a more diverse representation of different types of plastic polymers in there. But again, some dominance by polypropylene and polyethylene again. But we're also seeing the grey shading in those 2 bar graphs is from polyurethane. And polyurethane is used a lot in all manner of coatings. So that's paints and surface coatings, so on buildings and these sorts of things. So again, that's probably why we're seeing a polyurethane dominate in the small size fraction, because it's little bits of wear and tear and abrasion on all those coatings. And those little particles will be moved with stormwater into the Whau. One thing I'd just like you to, if you look at the left-hand side of the slide, the pieces of large microplastics are sort of up to 50 or so per kilogram of dry sediment. But if you look below that, at the small microplastics, we're up to 11,000 pieces of those small microplastics per kilogram of dry sediment. And that just reflects the fact that you know, they're much smaller, there's a lot more in the environment, and they're being washed into those receiving environments. We don't have much other data that we can compare the small microplastics with, because they're pretty really analyzed. So whilst we can't compare it, it's also great that we have this small fraction results, because this is pretty unique. One other thing is we can see from the results that the upper Whau catchment site generally has larger quantities of the large and small microplastic residues. And at this stage, we're unclear as to why that might be the case, but we'll be following that up with these results. Thank you very much. Ngā mihi, that's me.
Sure, everyone. This is a chance for you to participate, so go to menti.com and type in that code and answer the question for us.
Kia ora koe, tēnā koe. Tēnī te mihi kia koe, ko Hori taua taku ingoa, ko te Kawerau Maki, te iwi, ko tainui te waka, ko puku tōtara te maunga. Whānau au ki Pukaki, Mangere, e tamariki au, ka haere hoki au ki Waitakere. Reira, taku matua, taku māma, e putua taku au. No reira, tēnī te mihi kia koe taku tuhine, tēnā koe. As I said, my name is Hori Winikerei Taua, but everybody knows me as George. I was born at Mangere, but at a very young age, we moved to Waitakere, to Bristol's Beach, Te Hau, Waitakere, a place called Waiti. And I did a lot of my growing up there before moving back to Mangere, where I attended school. The subject today is about wai, about water. To me, wai is very important. Water is very important, especially to us, the Māori people. Water we use for blessing, you have to respect. Water is a thing that you can't just ignore. Growing up in the early days, especially out of Puke Tāpapa, our awa was called Oruarangi. Oruarangi was actually named after Ruarangi. Ruarangi was a ancestor of not only Te Kawerau Maki, but also of Waiohua, Ngāti Ahi Waru, or we called it creek, but in those days, Oruarangi awa ran from the Manukau Harbour right down towards Auckland International Airport. At the end of the awa is where we dug up all this black mud. In those days, we used it as dye for our pew-pews. To make your own pew-pews for kapahaka, our parents had to make their own. And if you picked up a piu-piu, you'll always see the black lines across. And that black mud came from the awa at Ororangi. And funny enough, that was the only place that you could get black mud anywhere in the Manukau or even in the Waitemata awa. The awa at Te Hau, which is known as Waiti, is very important to the Kawerau people. The water there was used for blessing, baptism, medicine. You got a water and you bless the person, no matter where you are. No matter where you go in Tamahi Makaurau, water is very, very important. I've got my mokos together and I've told them about our whakapapa, starting from Maki all the way down to the present day. That's important because there won't be many young kids like 5 or 6 year old would know their whakapapa right up way back. Not only that, but I've actually put it on paper so they can read it and they can just add the name to it as they go along. Today I think the water's been abused, a lot of rubbish been thrown into it, it's been polluted, and I think what I'd like to see is to clean up our rivers so that it'd be safe for everybody to go swimming, to enjoy. Water's there to enjoy.
Tēnā koutou katoa. That handsome man. Oh, I'm lucky that he's my dad. Tēnā koutou katoa ko Robin Taua-Gordon tōku ingoa, no Te Kawerau Maki Hau. Kei te kōrero kia koutou pāna ki te Whau. So kia ora everybody, my name is Robin and I am a member of Te Kawerau Maki, and my 10-minute slot this afternoon is to talk to you about the historical and current actually and cultural connections that Te Kawerau Maki have to the Whau River. Te Kawerau Maki, we call it Te Whau. We also call it Te Wai o Te Whau. And this afternoon I'm talking about Te Whau, He Waihono, the connector, the Whau River as a connector. So for those of you who are joining from across the motu, across Aotearoa, the Whau River is a connector of, first of all, it's of harbours. So it runs from the Waitemata Harbour, run through, and then you, back in the day, you used to go up the river on the waka, get out of your waka at the end, walk it up Portage Road, which is called Te Toanga Waka, and then you'd be in the Manukau Harbour. So it's a connector of harbours. Te Whau is a connector of people, so it provides the opportunity for people to come together and connect with each other. Te Whau is also a connector of people to nature, to the whenua, to the environment, to the awa. And so my kōrero this afternoon, what I wanted to do was just share a little bit of cultural history with you from the Te Kawerau Maki perspective and give you a little bit of background in terms of some of the names that Te Kawerau Maki use across the river, along the river. And I think the names that Te Kawerau Maki have used for this space indicate how important the water and the awa is to us. And the names also signify the connection of Māori to the water. So as you can see on this map here, we've got Te Whau, and one of the first places that we call, one of the first names that I'm looking at this afternoon is Kai Araara. Now Araara is a trevally, and this tributary here, it's by Lauriston Park. It was called Kai Araara because that's where Māori used to catch trevally. We've got Wero, which is the river right next to Archibald Park. And once again, Wero relates to fishing and gathering kai from the awa. We have this place, which is actually on the other side. So it's by the where the West End Rowing Club is, and that's called Hokawa. And it's called Hokawa because of the southeasterly winds that used to hit that side of the river. So depending on the weather or depending on the season, some Māori would stop there and shelter from those southeasterly winds that were coming through there. We've got Wai Marumaru, which is at the end of, or towards the end of the Whau River. And Wai Marumaru means a place of shelter. And in one of the photos at the beginning that Jinny had, there was a picture of some kayaks, and thank you to Hoopla actually for organising our kayak trip up there. But I remember when we were actually on the water, and when you get to the place where it says Wai Marumaru, the sheltered area, it actually is, the wind stops, and it's a beautiful, peaceful place to be. And then just as another example of how healthy that water was and how healthy that area is, this body of water, which is on the other side of the whau, over the Rosebank side, is called Arapatiki, and Patiki means flounder. So Arapatiki was named because of the path that the flounder used to take up that side of the river. Then we've got like these names, and the green ones are names that were given to specific parts of the whau because of the behaviour things that we did there. So we've got Te Rewarewa, and actually Te Rewarewa is the Te Kawerau Maki name for New Lynn. So if you live in New Lynn, you could also say that you're from Te Rewarewa. And Te Rewarewa means to float together. So it's an indication of where people would come together and travel together. We've got Te Kotuitanga, which is a little bit further up the whau, which is pretty much where Olympic Park currently is. So that's called Te Kotuitanga. And Te Kotui means to link, to interweave or to lace together. And so Te Kawerau Maki called that place Te Kotuitanga because that was where waka were bound and laced together. We've got up the other end, up here, this is called Rangi Matariki. And actually this is one of the most fertile places along the edge of the whau. But we called this Rangi Matariki because you can, when you're standing there, and you can go there today, it's where the go-kart place is. Anyway, if you stand there, there's a clear view shaft out to the Matariki constellation. So maybe in a couple of months you can get out there and have a look at that. So that's Rangi Matariki. But then if we go back, so I'm a little bit all over the place, there's this line here, and that's called Te Toanga Waka, which means the pulling of boats. And so in the beginning, when I said Māori used to travel from the Waitemata Harbour, come down the Whau River, take their waka out at Te Kotuitanga, and then walk it up Portage Road, which is called Te Toanga Waka, into Green Bay, Motu Karaka, and then they're in the Manukau Harbour. So the Whau River, Wai Te Whau, or Te Waifau, was an extremely significant body of water for Te Kawerau Maki, and actually for many iwi within the wider Auckland area. So I guess I wanted to share some historical, cultural connections with you from the Kawerau Maki perspective, but I also wanted to take this opportunity as a platform to put out a wero, to put out a challenge to all of you who are listening this afternoon. And so one of my challenges, one of my calls to action, or one of my wero kia koutou katoa, is how can we ensure that our behaviour protects the historical, current and future connections to the awa? How can we do that? What are the actions that we are taking? Another wheel is, what do I do to protect the mauri of Te Waifau? So once again, what are my actions? What am I actually doing? Am I talking about it? What am I doing? And I guess my third whero kia koutou katoa is, how can I share my connections to the awa with others? Because I like to, share the passion that we have and share the connection to those spaces with others. So hopefully they can become passionate as well and become kaitiaki of those spaces. So I just want to finish my kōrero. It's a nice tino poto taku kōrero I tēnei ahi. So it's a nice short one, but I wanted to get to the point. But here's a whakatauki. And the whakatauki is he mokopuna ahau, he tupuna ahau. And basically what that means is I'm a grandchild and I'm an ancestor. So the actions and behaviors of the people that have come before me, before my, my tupuna, our tupuna, have enabled us to be where we are. So we are grandchildren of them. However, later on, we are going to be tupuna, so we are going to be ancestors. So we need to make sure that the behavior, that our current behavior ensures that the future is strong and our awa, in this case, is healthy and sustainable and there for others. So ko o te taku kōrero I tēnei ahi, nō reira, ngā mihi nui, ngā mihi aroha ka koutou. I'm going to pass the rākau now over to, I'll just undo my slide and I'm going to pass it over. Nō reira.
Kia ora, Robin. Kia ora, everyone. My name is Hamish Allen, and I work as a marine scientist in the Research and Evaluation Unit at Auckland Council. And we're a team that undertakes all of the state of environment monitoring around the region. So we've got programs across the sort of air, land, and water domains. And the monitoring that we do aims to assess the health of the environment, looks to track the changes over time in that health and to identify potential issues as well. And what I'm involved in mostly is sediment contaminant monitoring. I'm going to talk today about what this is and what we've found from our monitoring in the Whau. Next slide. So first of all, what is it that we're monitoring? You've heard a bit today about emerging contaminants in the environment. Other contaminants that we've been monitoring since sort of the late 90s are levels of trace metals. So this is mainly copper, lead, and zinc. So these metals can come from a range of different activities and land uses. They can come from vehicle tire and brake wear as we drive around, from industrial waste and discharge, and from some construction and building materials too, as they break down over time. And what happens is when it rains, these pollutants get washed into our stormwater networks, into our waterways, into our streams and rivers, and they end up in our marine environment. And once they're there, they can start to settle and start to build up or accumulate in the sediment. So trace metals like copper, lead, and zinc, these occur naturally in the environment. So why is this a problem? Why should we care? Why should we monitor this? Next slide. And the reason is that human activities can cause levels of these metals to be much, much higher than they would be naturally. And this can start to affect the ecological health of an area. When you look across a sand or a mudflat, it can appear pretty quiet at first glance, not too much going on. That image on the top right there, that's from a site we have at the entrance to the Whau, just on the other side of the causeway. And when you look at it, you can see a few shells on the surface, but there doesn't appear to be too much other life. But when you look a little bit closer, living within and living on top of that sediment can be a really diverse community of animals. You can see some of them here. We've got shellfish, crabs, worms. Many of these animals play really important roles in the natural functioning of that ecosystem. And they even support ecosystems beyond that one as well. They can be really important food sources for a lot of our shorebirds and fish that come in and feed there when the tide is right for them. So a lot of these animals are really quite sensitive to copper, lead, and zinc. And too much of this in their environment will cause them to no longer be able to survive in that habitat. And over time, what you can end up with is really quite degraded communities that are just dominated by a few of these species that can tolerate those higher contaminant levels. Next slide. So where do we monitor? So we do this monitoring at 3 sites in the Whau and 1 site at the entrance. So we have sites in the upper, middle, and lower reaches. We monitor in those sort of clear open areas in the intertidal area. So that's the area that gets periodically sort of covered and uncovered by the tides. And if we look a little bit closer at a site, and these images on the right there, they're from the site we have at Whau Upper, you can see some sort of typical sediment surface. So all of those little holes there, they're all crab burrows. And for those that have ventured out onto the flats in the Whau, you'll be familiar with this, but it can be pretty muddy out there. And that site at Whau Upper has mud, it's sort of around calf to knee deep, and that's pretty typical for sites in the Whau. Next slide. So how we monitor. So we visit these permanent plots and we sample them about every 2 or 3 years. We don't really need to sample more regularly than that because contaminant levels in the sediment, these change pretty slowly and gradually over time, at least for metals they do. We take surface sediment samples, so we're looking at just the top 2 centimetres. And we do this because this is a sort of integrated mix of some sort of freshly, newly deposited sediment and some older sediment too that's coming from like deeper within the profile. And when we monitor contaminants, we also monitor marine ecology, and we look at sediment mud content as well. So we're looking at how much mud is in the sediment compared to how much sand. This is because mud in the marine environment is quite important, and that can also restrict the types of animals that can live there. Also, so muddy, low energy areas, they're quite prone to trapping and accumulating contaminants, much more so than those sort of sandier, more exposed sites. When we look at the results we get from our sites, we compare them with threshold levels, and these have been developed specifically for Auckland. They're known as the environmental response criteria. And this uses like a traffic light system. You can see that table there at the bottom right of your screen. We don't need to pay too close attention to the values, but we just need to make note that green indicates a pretty low level of contaminants. Amber is sort of moderately elevated, where we might start to see some impacts, and red's quite high level of contamination where ecological impacts and degradation are likely to be occurring. So what have we found? Next slide, please. So results from our most recent sampling in the Whau in 2020, these showed a pattern that's been pretty consistent with what we've seen there over the years. That's pretty low levels of contamination, so that ERC green status at the Whau entrance, but sites in the upper reaches of the estuary, they're more impacted by contaminants, and they're also a lot muddier than they are at the entrance to the Whau. So those low levels of contamination at the Whau entrance site, that's likely a result of the site's exposure. So when it receives a lot higher tidal energy and mixing, and this helps to remove it and dilute those pollutants as they sort of enter into the Waitawata. And when we look at the ecological health of these areas, they really follow what we see in terms of that metal contamination. So quite a diverse community of animals at the entrance, less so as we make our way sort of further up the Whau. The Whau and its catchment have a pretty long history of industrial and urban use, and it's this that has really caused over time the accumulation of metals in the estuarine sediment. Next slide, please. So the Whau is not alone in having these high concentrations across Tamaki Makaurau, and we see this in other areas where there's similar types of land use. When we look at a regional map, and this is for zinc, you can see other hotspots of metal contamination, particularly where there is those long histories of industrial and urban use in places like the Tamaki Estuary, Henderson Creek, and in the Mangere Inlet too, in the Manukau Harbour. So that's where we're at today. What about over time, and have things changed in the Whau over the years? Next slide, please. So sites in the Whau have shown pretty elevated levels of at least one metal, and most commonly this has been zinc, right since the start of monitoring back in 1998. And overall, the sort of changes in metal contaminant status, so whether a site's been green, amber, or red, that stayed relatively stable. We don't really see sites jumping from green to red or vice versa. As I mentioned, like these changes in contaminant concentrations occur pretty slowly over time. But if we look a little bit closer at the data from the sites in the Whau, we can start to see some more sensitive changes or trends occurring over time. And one of these is a reduction in the heavy metal lead. And so we see this at all the sites in the estuary, but we see it most strongly at the site Whau Upper. You can see that graph there on the bottom right of your screen. You can see those levels of lead decreasing over time, going back up, I think, to 2004. And lead levels have been decreasing at sites right across the region, and mostly this has been happening due to its large-scale removal from petrol in the mid-90s. So that's really positive. What we're seeing though at the entrance, at the site at the Whau entrance, is an increase in muddiness. So less sand, more mud. And with an increase in mud often comes an increase in metal contaminants as well. And this is because these metals like to stick to and like to accumulate in mud more so than they do compared with larger particles of coarser sand. So yeah, despite this, the sort of current concentrations at that Whau entrance are still relatively low. We still wouldn't be expecting to see some any impacts on ecology. Next slide. So just lastly, guys, just a couple of points on reducing metal contamination. So vehicles on the roads are a pretty major source of metals from brake and tyre wear. So if we can reduce our use with public transport or bikes, that's going to help reduce contaminant loads into stormwater. Being involved and active in restoration planting, particularly like riparian planting around our waterways, this helps to trap and filter not just those heavy metals, but a range of other pollutants as well. Auckland Council also undertakes some pollution prevention programs and evaluates and assesses different opportunities to improve water quality. So in industrial areas, if you're a business owner, you can request a specialist to come from Auckland Council to visit. This is non-regulatory, it's sort of education-based. Do a site assessment, look at potential pollution issues, and this has taken place at a number of sites earlier this year in sort of Newland, Portage Road, Cawthron areas. They'll look at your storage, disposal, offer some waste minimisation techniques, and provide spill training too to make sure you're well equipped to handle that. So yeah, kia ora everyone, thank you for listening. I'm going to pass you over now to Kevin from the University of Auckland.
Kia ora koutou katoa, ko Kevin Simon toko ingoa. Hi everyone, I'm Kevin Simon. I'm an environmental scientist at the University of Auckland. I'm going to talk a little bit about some research that my students and I have been doing. We focus a lot on understanding where microplastic is in the environment, how it moves through it, and what sort of ecological effects that it has. And I'm going to talk just about one of our projects where we focused on a number of sites in the Whau River catchment, so lots of small streams there. And so this is done as part of the AIM2 research project, but also in collaboration with some of our community partners. So if you go to the EcoMatters website and look for the Te Hau Te Whau segment on there, you'll be able to find the map of all the places that we've worked, the places that I'll show you data from. And so we really had for this project just three seemingly simple questions. So how much sort of litter and microplastic is in our streams? And so everything from large debris down to very tiny fragments of plastic. Now we asked, is there a relationship between the amount of that large litter and those very tiny particles of microplastic? And then ultimately we try to explain, why do we see more plastic in some places than others? The work I'm going to show you was done by a really amazing, enthusiastic student, Anastasia Zaletta, and this is part of her master's research project. And this gives you an idea of sort of what she was doing in these streams. So it takes a lot for a student to get out there in these urban streams and do this sort of work. So it's a real credit to the effort from Anastasia. And just to give you an idea of what Anastasia was doing, so she went out to all these small streams that feed down into the water that flows down into the larger Whau River. And she worked in small segments at each stream, so about a 30-meter reach of each stream. And she sampled across transects within each of those reaches along her streams. And she looked in the water, but she also looked up on the land as well. And I'll just show you the results from the water. At each of those places, she collected sediment and water samples to look for microplastics, so very tiny particles of plastic. She also did surveys of large litter debris in the stream and up into the land adjacent to the stream. Now, doing this sort of work, especially for the microplastics, is tedious, it's difficult, it's time consuming. And so she would take these environmental samples, either water or sediments. She had to extract the small bits of plastics in the laboratory from the sediment. She had to digest away chemically all the organic other material in the sediment. Take that material, filter it, stain it with particular stains that will cause plastics to fluoresce under a microscope, and then she counted every single particle that she found at these individual sites. So it's a huge amount of work. It's very difficult to quantify the amount of plastic that's in our environment that are these very small bits and pieces. And so I'll just show you some of Anastasia's results. And so the map on the left-hand side, again, these are all of our individual small streams throughout the catchment of the Whau River. And the larger and redder the dots are, the more large litter, macro litter was present at that given stream. The graph on the top right-hand side shows you the individual sites and the amounts that we found. And I suppose the take-home message here is that even at our lowest amount of litter at our sites, it was on average 1 piece of litter for every square meter on the bottom of the stream. And that ranged up to 8 pieces for every square meter on the bottom of these streams. The bottom panel just shows you what that large debris, that large litter actually was. And you see a lot of these big blue portions of these bars. So each individual stream, most of it was made up of plastic material. And so we find lots of things, but plastic is a pretty big portion of the litter that we find in our streams. The next two maps are just showing you the microplastic. So these are the very tiny fragments of plastic that we find in the sediment on the left-hand side and in the water on the right-hand side. And again, you can see there's lots of variation. And so for the amount of plastic in the sediment, we're ranging from upwards of 4,000 pieces of microplastic per kilo of sediment down to lower amounts. And in terms of the amount of plastic in the water, we're finding anywhere up pushing up towards 1,000 particles in a cubic meter. So one particle in every liter of water, down to some lower levels. And I guess the other thing to keep in mind is that if you look at these two graphs, they don't look exactly the same. And so what we see in the water and what we see in the sediment can be rather different at a given place. And so that microplastic that's in your awa, what is it? And so the top panel here is just showing you the distribution of different sizes of those microparticles. And for the most part, the microplastic that we find is quite small. And so for the most part, it's less than 500 meters. We went down to 63 microns in size. And so the vast majority of those microplastics are quite small. There'll be plastic even smaller than that, but analytically, it's extremely difficult for us to try to measure it. Most of those pieces of plastic are very small fragments, or they're fibers across these sites. And there's some variation from site to site, but those are pretty common outcomes. And I guess finally, I'll just leave you with this one. If we think about all that large litter that's in our streams and all those very tiny bits of plastic, we might ask, well, are they related to one another? Do we see a relationship between the two? So more litter, more microplastic. And so these plots are just showing you that. So the amount of microplastic on the bottom here and the amount of microplastic at the top. And so we might expect as the amount of macroplastic, large plastic in the stream goes up, shouldn't we see more and more of the small things? It turns out that it's not that simple. And there are really two reasons for it. One is that those small bits of plastics aren't just formed from the big things in the stream. They're being washed in from other places. And the other thing is that those very small bits of plastics are really easily moved down the stream. And so when we look at microplastic in a stream at a particular place, it came from somewhere upstream. And so I guess a real key take-home message is that what we do in one place really is going to be carried and transferred down our awa, and in this case, down to the bottom of the folk catchment. So our actions in one place can really be transmitted and moved throughout a catchment. And so that's a quick overview, and thanks very much for that. We have another student who unfortunately couldn't be here, but Matt has recorded a nice video for you, so I'll let him introduce himself.
Kia ora koutou e hoa mā. My name is Matt Perryman and I'm a master's student based at Mass University, and I'm looking into plastic pollution around the Whau Awa catchment. Here's a bird's eye view of the Whau Awa. You can see that it's in a pretty busy area. It's industrial and residential, so it gets a fair bit of pollution. But pollution, especially the plastic stuff that's light and more buoyant, also flows into the river from overseas and the ocean currents that flow up the awa. So it can be really difficult to pinpoint where the rubbish is exactly coming from. But the thing is, a lot of plastic rubbish that we find at our cleanups are marketed as single-use and disposable products, which makes no sense because plastics are designed to last a really long time without biodegrading. So once they get into our natural environment, they can stay there for centuries and can cause a lot of harm. And by that point, it's really hard to get them out. That's why for my project, I've teamed up with EcoMatters, Te Kawerau, Maki, ESR, and some other groups working around the Whau to do something called a brand audit. And a brand audit involves collecting as much plastic rubbish from the Whau Awa as we can find to collect data that tells us which brands or companies are polluting the awa. Focusing on the plastics, because that's the stuff that never breaks down. Will break down to microplastics and nanoplastics, but never actually biodegrade and become part of the natural system again. Brand auditing has been going on for years now in other countries, but we're some of the first people in Aotearoa to be doing it. It's important because we can use this data to call for more regulation around plastic and how it's produced and used. Because the only real way to stop pollution is to turn it off at the tap, or in other words, minimize plastic production worldwide. This is really critical because for a long time, the message that we've been receiving is that it's up to individual people to solve the pollution crisis by recycling and not littering. But our recycling infrastructure is actually way too small to match the amount of plastics that are regularly brought into and consumed in Aotearoa. This is also the case in many places overseas, which is how we end up with so much plastic in our oceans and in our lands and in our atmosphere as well. So really, recycling is not the answer. We need refill and reuse systems, which is why we audit the brands polluting the Whau. We want to communicate with them, these companies, policymakers, and our communities, that plastic products and the toxic chemical additives that they come with are bad for us all. Stopping unnecessary plastic production at the source is how we can genuinely stop more pollution from entering our taia. The dream is to get the Whau back to a state where it's clean and abundant, where you can go swimming and you can go fishing without having to worry about getting sick or ingesting microplastics, whether it's through the water or through the fish that you might be eating. We're doing another cleanup on April the 2nd, but there are limited spaces. So if you want to help us clean up the Whau, flick me an email on mjperryman@gmail.com. I'll put that up on the screen here. Ngā mihi nui for having me today, and I hope you all have a great weekend. Thank you very much.
Kia ora everyone, can you see my screen? We good? Tēnā koutou katoa, ko Pamela Gill tuku ingoa, kei te mahi ahau mō EcoMatters i New Lynn. I work on stream and environmental restoration projects in West Auckland. Today I'm going to talk about some of the work I'm either involved in or know of in the Whau. I wanted to celebrate some of the work being done to care for our natural areas, which has the Whau River and its network of streams at its heart. The Whau Wild Link is a network of community groups and organisations undertaking environmental work to create safe, connected and healthy habitats for native wildlife in the Whau. We're thankful to the generosity of the Whau Local Board for their support. This map highlights some of the environmental initiatives that have been taking place across the Whau over a number of years. It's not an exhaustive list. There are other projects. However, these are the ones that I'm connected with via the Whau Wild Link or have responded to my shout out to include in this presentation. Some groups are place-based while others work throughout the entire area. The Industry Pollution Prevention Program aims to give businesses the tools and understanding to prevent pollution in the Whau, particularly for our waterways. The Te Atatu South Society Totally Against Moth Plant, also known as STAMP, supports landowners to recognise and control the highly invasive weed moth plant. Moth plant is a tyrannical weed to many in Auckland. A number of individuals and groups in the Whau are working to control this weed from overtaking backyard gardens and our natural areas. Glendine Stream flows through the Glendine Reserve in the heart of this suburb. This group is focused on trapping, weeding, planting, stream care, as well as celebrating rongoa rākau in this reserve. The Whau pathway follows the traditional portage of the Whau from the Waitemata through to the Manukau Harbour. This pathway is at various stages of planning, building and completion. There are many other aspirations to the wider Te Whau pathway engagement, such as these points noted here. Friends of Kurt Bremer are working on a section of the walkway on the Rosebank Peninsula along the Whau River, reclaiming land from invasive weeds and replanting with natives, aiming to provide healthy habitats for birds, prevent silt entering the river, provide a place for people to enjoy and a chance for the community to help the environment. Moth plant awareness raising, education and control on private lands are a focus for these locals on the Whau River between Ash Street, Great North Road and the Avondale Racecourse. The hoopla, it's about getting up close and personal with the water and seeing the land from a different, often hidden perspective. They run Haere Mai Ki Wai Te Whau, a series of guided kayaking tours focused on building relationships and support of improving the environment around the Whau. A Chinese community group that are learning by doing whilst supporting environmental groups throughout the Whau Wild Link area. This is an opportunity for them to learn about the natural indigenous environment of Aotearoa and all that impacts on it. Te Waiora or Te Whau project works with schools, community groups, interns and volunteers to improve the mauri of the Whau Awa and its many tributaries. We've had the support of Te Hau Te Whau master's students, Anastasia and Matt. The aim is for our streams and streamside areas to be thriving habitats loved and cared for by the community. Growing the Whau, a weedy project, working with community to control environmental weeds on public and private land with a particular focus on moth plant. Providing advocacy, education, planning and support to restore backyard gardens and larger restoration projects. He aha te mea nui o te ao, he tangata, he tangata, he tangata. What is the most important thing in the world? Just people, just people, just people. In this context, I don't quote this whakatauki to place people above our environment, but to note that we're interconnected with Te Hau, that we have choices as to how we support, care and nurture this relationship. If you'd like to get it to help out on any of these projects in the Whau Wild Link area, please get in touch. Nō reira, tēnā koutou katoa.
Kia ora everybody and welcome back. It's been absolutely wonderful to hear from all of our panel today, and we have had the opportunity to listen to some experts in their field, and our thanks goes out to everybody in our panel who's given up their time to actually join us today. We have had some great questions coming in from the audience and from participants in this webinar, so my thanks to you. And with no further ado, we would like to get underway with the questions to the panelists. So I'm going to start with a question that has come in from Meg, one of the participants. She's asked a question that I'm going to direct to Grant. And the question is, has any research been done on microplastics in seagrass in the Manukau Harbour?
Great question, and to the best of my knowledge, no, it has not. But it's interesting that that's being raised by one of the participants, because it's something that Olga is very interested in because of the unique and vast range of environmental services that seagrasses contribute to environmental well-being, not only here in Aotearoa, but around the world and the locations where those ecosystems predominate.
Wonderful, Grant. Thank you very much. We have a question coming in, which I would like to direct to Ron. So, how do we make sure that we also recognise the kaitiaki of other iwi with whakapapa on the whau?
Okay, thanks, Carla. To be honest, I actually can't talk about any other iwi because my hat is firmly a Te Kawerau Maki one. But I don't think that it should just be limited to other iwi. I think we all have a responsibility to be kaitiaki of the awa that's in our backyard. So I think it's a call to action for all of us. Ahakoa no he koe, ahakoa ko wai koe. So it doesn't matter who you are or where you're from. If you're there, it's your taonga. So we all have a responsibility to be kaitiaki for that.
Thank you, Robin. Fantastic. Thank you very much. So just looking at some of the other questions coming in, and another question from one of our panelists, and this is a question for Kevin. Why would there be different amounts of plastic between sediment and water in some areas?
Sure. I think one thing to keep in mind is that when we collect a water sample, it's the plastic that happens to be moving by at just that point in time. Whereas the plastic that's in the sediment has been accumulating over time. And so that material in the sediment sort of integrates change. And so if we went back and sampled the same stream, maybe even a half an hour later, a day later, it's probably quite different in the water, whereas the sediment kind of is a slow accumulation of material. So, yeah.
Wonderful, Kevin. Thank you. That's a really good answer. We have a question from Sonia. And she would like to know, do microplastics leach into the groundwater and aquifers. And I'd like to direct that question again to Grant.
Hello. There's been very limited studies worldwide on the predominance or the presence of microplastics in groundwater. But some work has been carried out in North America where you have very porous limestone geographic areas. And in those geological situations, you can have cracks leading down into groundwater, surface on the surface, sinkholes and the like as well, which act as a conduit. And yes, residues of microplastics have been detected in the groundwater under those, within those geological areas. Here in New Zealand, there's been no national survey of microplastics in groundwater, but in the program that I co-lead with Olga, some preliminary work is going to be undertaken over the next 18-month period in consultation with Olga's colleagues at ESR, because they have quite a number of experts on contaminants in groundwater ecosystems.
Thank you, Grant. Wonderful, wonderful answer there. From Kathy, one of our participants, and I think this is a question that many people want to know the answer to, and I would like to invite Olga, who hasn't presented today, but I think is the right person to direct this question to. Are there ways we can remove microplastics once they're actually in our awa?
So there's been a lot of work being done trying to remove microplastics from water and sediments and from wastewater to try and stop them getting out there in the first place. And they have found ways to do it, but it's scaling it up. And also, because they are so small, if you're pulling out the microplastics, you're also pulling out a lot of the good things that ought to be there. So the microorganisms and the small insects or the algae, all the things that need to be in there, they can be stripped out at the same time. Or the processes that are used, they actually may kill the things that you want to actually stay there. So there's a huge amount of work being done to try and find a way that's suitable to remove the plastics and also protect the environment at the same time.
Thank you, Olga. Thank you very much. That's awesome to hear. I would like to direct this question to Robin. What will give you confidence or assurance that the changes and actions we can take are making a difference to the whau? And actually, Robin, I'm not 100% sure if you are the right person for that question, but
I'll give it a go. And then if anybody else wants to add their pearls of wisdom and knowledge, feel free. And my answer will be really short, actually, because I think Pam summed it up when Pam talked about interconnectedness in her presentation. I think it's that whole connection between people and the awa and the behavior of people and the health of the awa. So yeah, I think it just goes back to my original kōrero about all of us being kaitiaki of that whenua and yeah, actioning what we espouse, I guess.
Thank you, Robin. Hamish, we have a question coming to you. Why is it getting muddier at the entrance to the whau?
Yeah, thanks, Carla. Yeah, that's a good question. And the entrance to the whau is still quite sandy. It's still got about sort of 80% sand. It's hard to know for certain, but as sort of estuaries evolve, more sediment comes into them, they start to fill up. And this happens over thousands of years, but it's happening a lot quicker in the whau. And that can, as those sort of channels and that sediment substrate starts to get close to the surface water, it starts to be sort of remobilized and it can start to shift into different areas. So that could be what we're starting to see at the entrance to the whau. Maybe we may start to be seeing it sort of exporting some more of that sediment out of the whau rather than it settling in the estuary itself.
Thank you, Hamish. Excellent. We have another question coming in from a panelist, and I would like to direct this to Louis. What emerging contaminants are of the most concerning to the scientists?
That's a very interesting one. You know, the approach that we've taken with, you know, how we're tackling the management of those emerging contaminants is to set our net very wide. So we're looking at the whole range of whatever contaminants can enter the environment. And then what we're trying then to do is come up with a long short list, if you want, of those chemicals that are posing the highest risk. And then going back to where their sources are. So if it's a pesticide, how can we better manage them? If it's an antibiotic, so that's the sort of thing, you know, raising stewardship, for instance, with those chemicals. So I think it's an interesting question, because sometimes it doesn't mean that you have a chemical at a low dose or low concentration that it doesn't cause a problem, because if it's really highly toxic, so then we really need to. So that's why there's no easy answer for this. And it's part of this research, and it's not just in New Zealand, it's a question as well for globally, you know, what are those ones where we can get the best environmental gains from better managing them. So sorry, it's a very vague answer, but we're working on it.
Thank you, Louis. Thank you very much. A question coming in from a participant to Robin. Kia ora, Robin. Whilst we're looking at these contaminants in the Whau, what impact does this have on your ability to harvest kaimoana from the river?
Yeah, kia ora, Anna. Thank you for your question. To be honest, we haven't been able to harvest any kaimoana safely for a while. And the fact that the study is being done, hopefully we can actually enforce change at the legislation end, at the community, you know, at our end, and hopefully we can get back to that. But to be honest, we haven't been able to harvest for a while.
Thank you, Robin. Thank you very much. So I would like to just take a moment to thank all the participants for the excellent questions that are coming through. I know many of these questions top of mind for all of us. And as we come to the end of our presentation today and our webinar, I wanted to give everybody an opportunity to think now about the wero that Robin laid down to us, the challenge that she laid down to us. And that is, what can we do? What actually can we do? What are the steps that we can take? And I think one of the things that has really resonated for me is the actions that we all take individually, surmounting to actually a really big impact on our awa and the health of our awa. And being able to actually talk about this with our whānau and with our friends, spreading the word and just sharing the knowledge that you've actually gained today. But really just a reminder that there are so many things that you can actually do in your own home to make a significant difference to the health of our awa. And in particular, a really big call out and a reminder to everybody that only rain should be going down our stormwater drains. That is the only thing that should be going down our stormwater drains. Again, I'd like to do a really big shout out to the Whau Local Board, the Henderson Massey Local Board, and the Waitakere Rangers Local Board for making the EcoFest West Festival a possibility. And lastly, as we close off today with a karakia, kua mutu a mātou mahi, mō tēnei wā, mana ki tai ma te katoa, o mātou hoa, o mātou whānau, au kia te aorangi. So my thanks to you all for joining us today. It's been a pleasure to have you with us. Again, a big shout out to everybody in our panel. We really appreciate you being here. Have a wonderful weekend for the rest of it, and thank you all.